So I got myself this new to me 3-phase motor, which I'll be running with a VFD, and the plan is to install it on the underside of the workbench and have a hole for a belt to go through, so I can make my own tools that can be run by it. And the first tool I'm going to be making is a belt sander. I'm going by what's available in my local stores, so that it's not a pain to replace. And to go to the higher grits, I have to go to a smaller belt. So what I'm going to be doing is making the belt go around in a triangular fashion over the rollers. And so because you've got 3 rollers, you're going to be adding, to make it bigger for the smaller belts, I need to add a certain amount. We'll get into the details of that when it's time to go to the design phase. But essentially, I'm going to have the offsets on the guide rollers, and the drive roller is going to be the same size for all of the belts. And it's going to be built with some U-channel. This is going to be a steel plate for the backing. This piece of scrap is going to be the table. It's going to be able to swivel. Yeah, it's going to be lots of fun.
Right.
You know what they say? Cut once, measure twice. That's exactly what I did. I bought a bunch of random cut-offs and designed around it. Had to measure quite a bit to make it work.
Yo voy a cantar esta canción para mi gente, con una pasión tan fuerte. Ay, 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 ahora sigo cantando y sigo gozando, yo sigo cantando y sigo gozando.
So there's been a bit of a change of plan on how I'm going to be making the whole machine, but that I'll get back to later. You can see why I don't film very much while I'm turning yet. I need to set up a jig for the camera, but I'm just at the point where I'm finishing up my second roller like this one, and so to get the tolerances so that I can press fit the bearing in, if I can. So yeah, so if I can get the bearing in, I'll just show a bit how I'm measuring as I go, just because I'm not good enough, to be honest, to just use a measurement from the beginning and then just go with my gauge on the handle, and I don't have a DRO, so what I did was I zeroed my digital caliper on the bearing, and so, come on, this is going to be really annoying if I can't focus anything. There you go. I zero it on, and so whatever I'm off by when I measure the inner diameter that I'm cutting, that's what I've got left to cut. So this says I am about 8.5 thou off. So I'm gonna do just a cleanup pass, really just to say, but I'm going to leave it like that after. Yeah, see, it's the taper, and if it's going at a bit of an angle it wants to go in. If I push it in right now it'll get stuck, so actually I'm not even going to do a cleaning pass on that. I'm just going to clean the bottom, but the edges I'm going to leave as is. And once I flip it around and do the other end, then I'll show how I press it, because I don't actually have an arbor press or anything like that. So like I was saying, I'm going to show how I press these on. So I make sure that it goes in parallel. If I push this even slightly, it'll get stuck. I had that issue yesterday. And then I just bring the bed of my mill up under the waves, because I know that's flat. And the amount of pressure going in there is not that massive, it's just that I want it to be perfectly flat. Well, alright, apparently I made that hole a little bit small, bigger than I thought, but so that's not quite pressed at all. But it is a snug fit, like it's not falling out. So anyways, I know one of the sides was I tested and it was definitely going to be a press fit, so that's the one. And then to finish it off, I just put a second one on top. This is clearly not concentric also. I really screwed this one up yesterday. When I flipped it around to turn it, I used an indicator on the end, and everything seemed to be within a thou. And then I ended up with pretty much half a crankshaft. It must have been bent or had a big curve in it or something right at the end. And anyways,
just for a bit of context, this was from some
that's a do-over.
Steel.
Let's see.
And the ends were flared, and this piece was from the end of a rod. So.
Yeah, 1.92, 1.57. Considering the size of this, that's a massive difference. Anyways, whereas the other side, you know, everything's nice, so. Anyways, that's how I go about it, but this piece was a huge disappointment, but yeah, well, I guess I'll try again. course, I forgot to turn on the camera for the last bit, but I just cobbled together this lathe dog because my big one, well, it's too big. It's the only one I've got, so, you know, took a bit of time aside just to throw this together, and it's a really good feeling when you're at the point where you can make your tools to make your stuff. Yeah, it's really cool.
Hey, it's 5 in the morning. I've been up for a while now and had some time to do some housework, dishes, stuff like that. So while everyone's still asleep and stuff is done already, I guess I have a bit of time to finish this. It's been I've unfortunately had issues with my camera, but I just wanted to go over it because it was probably the funnest piece I've ever, not necessarily the most satisfying piece I've ever made, just because of how well it turned out. I don't know how much of the footage I'll have recovered by now, but well, by the time you're seeing this. But yeah, the bore is just absolutely perfect. I mean, it is super smooth, and aluminium is way easier to work than steel. I mean, that's no surprise, but anyways. So, I mean, the tolerances on this are just, they're pretty much ideal. So I have to press relatively hard for it to go in, but I can finger press it. So that's not going anywhere. And there. I don't know if you can hear it when it comes apart, but I won't do it too many times because otherwise it'll wear out and get sloppy. But I'm really happy with how that turned out. So now the challenge with it is going to be to cut some slices out of it. So I just want to show what I've been using. It's this super color marker. It reeks when you open it. It's essentially a paint marker, but I really like the half-inch or centimeter plus felt tip. It's really hard, so it doesn't fall apart like Sharpies do when you scrape it by accident on burrs and things like that. It does a real good job, and it dries really fast, which is probably why it reeks so hard. I mean, the solvents go away quick, but whatever. And of course I forgot to press record. What I was saying is the issue I'm having with using end mills as or just any parallel cylinders under the part is to be high enough they have to be wider than the width of my piece. So what I've done is I've used 3 bearings. So by ensuring that there's a tight contact on the 3 bearings placed in essentially a triangle, so 2 of them side by side, 1 of them further out, I'm creating a plane, so at least it's going to be somewhat leveled when I flip it around, at least close enough for what I'm doing. And it's also going to help take some of that downward pressure. So you missed all the fun, but you know, did some tweaking with the facilitator. So because the ideal would obviously be to not have to face the part, especially when it's so thin, what I did is with the machine still off, I just used the ways to just scratch the surface, make sure that it was going along the line and not overlapping it. And sure enough, you can still see the score line. And then I moved it another maybe 3 or 4 thou tops back to just give myself a little bit more clearance. Did the same on the side, although I can't do it nearly as much just because of physical constraints, but you know, I can see the same thing here. So here. So yeah, I guess I'm ready to go, and fingers crossed. Alright, of course my last shot was pretty off center. Oh well. I just want to take a break. I think this is pretty cool. Just from cutting. It just happened that the center part was almost exactly, come on, twice the width. Alright, there you go. Twice the width of the blade. It's actually really hard, so I'm guessing it's worked hardened or something, because it's really thin too. But yeah, it's really cool. I'm gonna try to keep it, see if I can end up with a little sheet, really thin sheet with just the hole in it at the end. Oh. Did I stop right before? Yeah. Well, I'm not going to bother putting that back in. I'm definitely going to wreck it if I try that. Talk about holding on by a thread. Sweet. So anyways, this is going to be the, yeah, this will hold the bearing for the drive spindle. So, because it's going to be holding it in the frame, I'm going to be able to tap screw holes. Ah, crap, I should have drilled and tapped the screw holes before cutting this all up. Now it'll be a little bit harder, but whatever. I guess it doesn't need to be lined up. Anyways. I digress. I think that's going to be about it for now.
So I still have to make the axles for the rollers, as well as weld the frame together and assemble everything, but that's going to be in separate videos. I hope you're going to stick around for the rest of the series, and I'll probably be doing other projects in between the release of the different parts of this project. So have a good day.